Afternoon, everybody. Thank you very much for coming. We're going to talk about something which is of real importance to pretty much looking after what we care about, prosperity, human life and safety. And that's how can we keep the aviation industry that looks after pretty much all of us around the globe as safe as it has ever been. It's currently pushing out some really good numbers on growth, and we need to secure it as we push forwards with digitizing and connecting. I've got two amazing panelists here, and we'll introduce them in a minute. But really, when we're talking about how we do this, then I couldn't ask for better panelists. It's a really complex topic of how we secure the aviation industry for the cyber threats we've got. This is the report that I wrote last year, which goes into a lot of the challenges. So my hope is that if you want to learn more about it, then please dig into it. It's available online. Just Google finding lift minimizing drag, it comes up. But what we're trying to achieve here is a safe and prosperous aviation industry with resilient trust and systems. We've got to focus on maintaining that safety. Because if we look at what we're digitizing and what we're connecting on the aviation industry now, it's everything from aircraft, air traffic control, airports, UAVs, all of the flying personal transport that we're looking at. We've got the supply chain, everything from 3D printing all the way out to how we look at the satellites for the communications. And then top left in that picture is actually a remote air traffic control tower where the people who are keeping the aircraft safe in and around their airport actually aren't at the airport, they're miles away. So this is just a snapshot of how we're digitizing the industry. And what that has done to the attack surface is make it large and complex. And securing that is going to be something that's going to take not just the aviation industry, but also tying into the amazing research community, whether you're working for a company or working independently, and how we can actually do that better and faster together. Because one of the things that you look at when you've got perspectives of where we are at the moment is, and these are some quotes that people have said about cybersecurity aviation industry, about whether you look at the quote top left, which is, we've got a real problem here and we're going to struggle to get people to do something about it, or it's not possible to hack an aircraft, or we are secure, but it's not possible. We don't want to say how secure we are, how we are secure. But if we flip that back to 1970s, when the aviation industry was trying desperately to improve its safety record, you'd get perspectives like it's going to take a major incident before we learn how to fix this and improve ourselves. It's just not possible to have an incident, and we are safe, but we're just not going to tell you how we're safe. The industry has matured a lot now, it's a lot safer, and we've got to start moving away from the fact that this will get better by itself, and we'll be able to cope. We've got to be proactive in making this work across the entire industry. But trying to get the vulnerabilities understood, fixed, and managed when you've got that complexity and sort of target audience of stakeholders is something that's going to be a real challenge. And that's why it's a massive honor to have, we've got Jeff Troy and John Sheehy here. So Jeff runs the Global Aviation ISAC. So that's not just it's not a US one, it's the Global Aviation ISAC. And he's got customers all over the world. And John, with IOActive, they've got a lot of experience in trying to look at vulnerabilities across the industry. So we'll have a quick chat and go through the panel, and then we'll open it out to questions. The first question I've really got is, the nature of the challenge we're facing is really difficult, and everyone's got a different perspective. But first of all, to you, Jeff, is what do you see as the nature of the challenge we've got right now?
Well, I'd say probably the first challenge that we have is you have a research community that likes to go out and test and try different things, and when you look at the aviation system, one of the pieces of the aviation ecosystem moves at about 500 miles an hour and carries a lot of people on it. So when it comes to people going out and trying to do research on an actual plane, that's certainly a challenge, because that's not a safe environment for trying to do research, and yet naturally, when you have people doing research, they find things that people want to take a look at. So trying to find an environment where people who are curious can have an opportunity to look at things is a real challenge. I think that's a key a key piece there. One good thing I know from the industry, from working our members, particularly very aggressively, thanks to a lot of work that IO Active and John Chee's teams have been doing, is to know that the aviation companies, and you've talked about it, right? The 70s, they looked at the number of accidents that were going on, and they extrapolated it based on how many people they thought would be flying on planes and how many flights there would be. And they figured that, 20, 25 years from the 70s, there'd be an accident a day based on how many there were a year. And they took the space for error and moved it, to the point where flying is now the safest way to travel. So they have that perspective, that safety perspective, that is pretty much driving the same adoption of digital systems onto the plane, where they have a lot of redundancies, a lot of multiple check type processes in place that pretty much give them, a greater level of assurance that those systems that are protecting the flight safety are resilient and can operate, regardless of anybody trying to attack them.
Thanks for that. And really what I'm sort of hearing right there at the very start was, how do you harness that creativity safely in something which is a safety critical industry? And John, with all of the researchers that you've got across IO Active and the perspective that you've had on this, is how do you manage that challenge of being able to find those vulnerabilities and actually work on them responsibly?
So that's always a challenge. There's a number of issues to be able to look at cyber physical systems in a safe way, and you really need to understand the physical impacts of those cyber physical systems so you can design an environment where you can safely do that. Or if you're operating in a live environment, know what the limitations of what you can do are and know it very, very clearly. And that's especially important in an industry like aviation, where if there is an incident, it can very quickly turn catastrophic. We've done work on ground vehicles, passenger vehicles, and if there is an incident, the outcome of that incident is relatively small compared to the potential for an incident in the aviation world. So those are key things. And it's really understanding what the acceptable parameters are. And it does take a lot of information, domain knowledge about the particular environments to be tested. And while our focus is on the cybersecurity side, we do go to the level of understanding the physical processes, perhaps in an industrial control system, or understanding vehicle operation. What systems are critical to vehicle operation? What systems are not critical to vehicle operation? So a reasonable, prudent, risk-aware set of guidelines can be created so that work can be done safely and do so in a way that builds trust with the manufacturers and users of those products. And we want to make sure that we are sharing detailed, actual information in a way to responsibly bring light to some of the concerns so that the representative stakeholders can go forward and get the resources they need to address those challenges. One of the other things that's important to understand is sometimes when you're looking at a cyber physical system, there are layers of safeguards. And while our focus may be on the cybersecurity issues or the digital aspects of that system, frequently there are other non-technical controls in place, whether they're physical or policy or operational, that may reduce the impact of our particular technical finding on a cybersecurity issue. And it's extremely important to understand and contextualize that risk. What we don't want to ever say is, we got Shell, we can do all these things, because that's probably not the case. And you need to understand, for example, in an ICS system in a refinery, there are physical controls that don't allow those systems to go over pressure. And having that context and that deep domain knowledge are critical to being able to provide a useful outcome of that cybersecurity research.
So with the layered safety aspects that are in place in the industry, how are we really going to look at building that trust? Because although the cybersecurity, if it's compromised or there's vulnerabilities there, it shouldn't cause a critical failure. But there is still a nervousness, understandably, from both the stakeholder trust and passengers trust and industry trust. So that could be a real blocker going forwards in trying to build up these relationships so we can be better, safer, sooner. Is that the only blocker that we've got right now, or are there other blockers that we've got to try and work through as an industry and set of stakeholders first? And stay with the question if you'd like to.
So I think for some of the reasons you talked about, the aviation industry is a little bit more insular than some of the other industries we've worked with. And so it does take a little bit longer to build trust. And they face a different set of threats than the passenger vehicle automobile industry faces. The automobile industry doesn't face the threats of bombings in vehicles. It doesn't face some of the security threats. Passenger vehicles aren't typically hijacked. And when there is an incident, you're dealing with 2 to 3 people, 4 people, rather than 300, 400, 500. And so understanding the context in which they operate is important to having effective communication, so that empathy is important. Understanding the particular risks and challenges of that industry, of the members and stakeholders of that industry, the airlines versus an airframe manufacturer versus an avionics supplier, is all very important. Are there other challenges? Certainly, and I think some of the good of the aviation industry has been this really singular focus on safety. What that has allowed is these digital transformations that you talked about are taking place, is there is a focus on specific aspects, but they may not take the broader look, and that's where engaging the research community, engaging people who have a different perspective, a diversity of thought, adds a lot of value. Doing so in a transparent way is also important. Everyone wants to build more trust in the operation of the aircraft and the operation of the airlines. The way you do that is you talk about potential problems. You reasonably categorize the risk. While there may be a digital exploit or a cybersecurity issue, what does it really mean for safety? What does it mean for privacy? How should privacy be addressed versus safety? And having those greater context allows the industry to be more effective.
And on that trust issue, traditionally, there's been a lot of cases where that relationship between the research community and the aviation industry has been fraught through to, there's a bit of giggling, and I understand exactly why. It's been fraught for various reasons. Jeff, you and I have spoken about the work you've done to try and increase trust in all of your customers so you can share data, good data about threats and vulnerabilities a lot faster. Is there anything that you've seen from building trust across your customers that you think would be able to help bring in the research community and actually help sort of learn lessons from a sort of wider perspective?
Yeah, so we've had a lot of success, I'd say in the past 3.5 years now that Aviation ISAC's been out there, almost 4 years, slowly building that trust. And it really requires a lot of personal engagement. So we've brought people together from, right now, our members are on 5 different continents, and 4 times a year we're bringing folks together to have face-to-face conversations. And then, we surround all that with daily engagement through our other services that we have. But we have really seen a marked increase in what we term in the aviation ISAC as wins, where people are recognizing information that was shared by somebody else and deemed it important. That's really how we measure our effectiveness. And seeing that growth of wins occur really helps to develop that trust. When it comes to product security, there's a challenge all the time between intellectual property and security. And where's that balance going to be where, hey, I can't show you this and have you help me secure it, because if I do, then my secret sauce is going to get leaked out to you, right? So how do I find that balance? So we found many of our members engage privately with companies like IOActive and other researchers that go out there, and they come in because they're not stuck in the paradigm of the company. They're not from their engineering group. They're not their cyber group. They just come in and they do that red teaming on their equipment so that they can get that outside perspective and maybe have somebody find something that was missed. What we do have, though, is people sharing processes. What are you doing about quality controls? How are you handling supply chain risk? Even how do you handle your red teaming engagements and things like that? We have a lot more conversations going on now where people are sharing those best practices, and that really helps, again, drive, I think, increased security. We call it kind of raising the skills of everybody, right? All boats lifted up, as opposed to just one or two players getting more skilled. As all those players get skilled, also, it's not just the plane, right? I mean, the aviation ecosystem is everything. Like you said, the air traffic control, the airport, the ground traffic control, the services, everything that's being digitalized, and analytics and the Internet of Things devices or services that are being added. Every time you add another thing, you add another risk. And so the more that the companies are sharing the challenges around these risks, the more that the best ideas can be shared and people can get more secure.
So in order to make us more secure in the industry and finding those vulnerabilities as fast as possible, working on them, patching them, yes, it can take a while for patches to go out across the industry, but that's being worked on to make that faster. But if you could try and give advice to the community about how to engage and what they can offer, what would you sort of, as sort of final points before we open it up to the audience?
So I think there's kind of 2 points for two different parts of the audience, and so on the aviation side, as Jeff mentioned, having the right secure development process, having a rigorous, repeatable process you follow to assess the security from design through implementation and maintenance is critical. From the research community, I think it's very important. We worked very closely on Ruben's most recent research with the Aviation ISAC to make sure that we had experts in the particular knowledge domains who were providing feedback on potential impacts of the cyber vulnerabilities he discovered. Those are really critical, and it's much more challenging for an independent researcher to be able to do a responsible disclosure if you need to disclose to 20 or 50 or more entities. Even an organization like ours with significant resources, a dedicated legal team, people who are responsible for coordinated responsible disclosure, it can be very tough to get to everybody and do so in the right time. And so one of the things that we've really seen in partnering with Jeff and the AISAC is they were able to get us in many cases to have a conversation with the right people in a very, very short amount of time. And so I would encourage the researchers who are doing independent work, to engage with those right entities. And I really can't say enough about the value of the ISAC. It's fostering trust and communication and knowledge sharing within the community. The next step, both for us as a set of researchers in the computer security space and the ISAC, is for us to partner up in a way that will let the aviation industry get used to us used to the aviation industry, and produce better results for all the stakeholders.
Jeff, do you want to say sort of final sort of words on that before we open it up?
Yeah, I would kind of emphasize exactly what John said, and I really think this exercise that we went through in the last 2.5 months or so was a win-win for both of us. We were able to get very important information. There were changes that had to be made by companies to secure things, but at the same point in time, the researchers were able to get a little bit more context so they could better understand what it is that they had, and that's important, I think, for everyone, because the industry obviously wants to make sure that anybody that has found something that they think could be an issue, that we're addressing it, and that's so that they understand, again, I guess that context around it, because there are so many other controls, and John mentioned also in aviation, that are outside of that just that digital component that help keep that safety, resilient system working.
Thank you very much. Now, I'm going to open it up to the audience. Stand up or just go for your question, please.
So I have a question that might be out of the scope of this, but I was wondering if you could talk a little bit about how formal methods play a role in aviation security, if at all. I remember reading a long time ago that a lot of satellite software uses formal methods, and I was curious if that ever plays a role in aviation. In Avionics or some of the control systems that actually control aircraft. And I know there was a DARPA program, you know about this, that sought to secure certain components of flight control software in a drone, and I thought it was successful. I think it was called HACMS. And so, so if you could talk to that, that'd be interesting.
John, you're nodding away. Do you want to take this?
Yeah, so I'm familiar with the...
Much of the questions you can...
Sure. So the question was about what are the formal methods applied to secure engineering design of avionics systems and used within the aviation industry. Specifically, the asker of the question asked about HACMS, which is a DARPA project which was focused not only on applications in the unmanned aerial system space, but also in other systems. And it was intended to ensure that there was reliable execution. And so it has varied depending on the systems and then the specific application within aviation. You're far more likely to see those formal methods used in military systems than in commercial and certainly general aviation systems. The formal methods do have a lot of advantages. One of the fundamental problems as we talk about assurance, whether we're talking about software or more complex cyber physical systems, is it's an NP hard problem. And being non-polynomial in terms of time, you cannot necessarily exhaustively test all the potential vulnerabilities. And so even looking at something like HACMS, that's one component of a broader system. And so as attackers, we look to exploit vulnerabilities in the systems, even if particular components are extremely secure. And sometimes that may be a human element. And maybe you display information to a human to make them take an action because that's what they were trained for. That produces an effect. So absolutely, I think it's good that we're seeing significant efforts made to improve the component security, but you can't get away from looking at the overall system or system of system security.
And that's one of the beauties about the aviation industry is that all of those safety elements are layered. So vulnerabilities in one layer might not necessarily actually cause something which is critical. Okay, I'll pass it over for next question. Go for it. And we'll try and smash through the questions as much as we can because we don't have much time. Go for it.
So this is an ISAC question. So what is, or has the ISAC started working on how, like, basically tackling the weakest link risks? So you have some stakeholders on this who operate on extremely thin margins and don't have a lot of extra money to invest in securing all of their stuff. But they're also some of your people who are relied upon by all the other interconnected system things, right? So I'm kind of wondering, what is the ISAC doing to try and identify where those systemic risks exist and how to shore up those weaker links that may not necessarily bring in the level of revenue and profit margin every year that they can spend on shoring stuff up?
Okay. So the question basically is, what's the ISAC doing really to help everyone, because not everyone's got the big budget, right, for security and safety. So again, one of the great things about the ISAC is we have airframers, airlines, satellite companies, service companies, airports, everybody in between the supply chains that are members. And because of the way ISACs work and the agreements, they are able to do exactly what it is that you're talking about, as opposed to having monopoly issues and things like that. Because we're not talking about prices of routes. We're not talking about, how you're going to set your seats up or anything like that. We're just talking about the security for everything. So having the airframers in there with the airlines, the operators of that, allows for exactly that type of discussion to occur. The airframers are the ones that are pretty much doing that from the design. It begins at design, then build, then test, then operate. And the big thing is as you build all that and you hand it off, right? There comes a point in time where those who have designed and built have to give it to those who operate. And this discussion in the building of the trust is allowing for, again, that free-flowing discussion of what is it that you all are doing once you've gotten that. Part of the issue that's come up, if you get a chance to see Ruben's talk tomorrow, has to do with hands-off of equipment, because it goes from someone who's built it to someone who installs it to maybe someone who replaces it and puts in another type of system. And each of those opportunities is also an opportunity for someone to make a security error. And so things like continuous monitoring, when it comes to what's considered a resilient system, has really kind of come to the forefront. I think that's probably one of the biggest things that's come out of the last couple of months. You can't accept anything as resilient, right? We all know you have to do continuous monitoring, and ensuring that that's happening even on systems that you think are delivered resilient is a big part of that now.
Okay, so the aim really is to try and make sure that we can find those vulnerabilities, maintain the system as resilient and as profitable and as safe as it has been really, across all of those stakeholders, and make sure we can do it in a way that the research community is brought in a positive manner. I think we can do it. I think that with the work of the ISAC and companies like IOActive and all the other research community, I think we've run out of time, sorry. That actually what we'll try and do is try and make sure that we can actually find those processes and those relationships and building trust so we can take this forwards. I'll give final sort of comments to both of you, but everyone we sort of will be hanging around afterwards, so we can answer questions if we missed you, for example. Sorry, Renderman. And then we'll hopefully pass it over. But final words to the panelists, please.
I would just say, over the last couple of months, we've been very actively involved, actually with a couple of researchers. So, we're mentioned with Ruben and IOActive, but we've had other engagements here where this model of somebody coming and disclosing something to the Aviation ISAC has helped them, specifically because by getting with us, we were able to get them connected to the right people right away, which was very important for both us and them. Again, context for the researchers and awareness on the aviation side. But the other thing that I think is really important, and we're seeing it, is when the vulnerability is found in one product. If you go to that one company and disclose it to them, give them a chance to fix it, and they fix it, and then it goes public, I think there's still a lot of risk in industries where other companies, maybe they didn't have that exact same functionality, but they probably have some similar type of functionality. And the methodology that was used to uncover that risk, we believe in the aviation industry, should be shared amongst the industry, so all of the other people who design and build to perform that same function can make sure that they don't have that same risk. Because, we're talking again about a huge safety issue, a huge economy, and by having everyone be able to relook at what's going on, then making it public, I think we've done a more a responsible thing in terms of safety and security in the industry. And I can say for sure that the information that was shared, the companies that were involved in this thing immediately made their corrections. But we know of many other companies that shared with us that it made them relook and rethink and start to go back and challenge themselves. And that, I think, is a win again for everybody.
So I know we're out of time. I would say, we work with a number of other ISACs, and the ISAC is something that's a little bit new to a lot of cybersecurity researchers, but it's a very, very, very valuable tool for engaging with those stakeholders who are exposed to the risks of the research.
So thank you very much for coming, everybody. It's a topic which will not go away, and I'm looking forward to discussing this lots more at B-Sides going forwards. But please come and speak to us afterwards, and hopefully we'll explore this so we can get it better. Thank you.